Well, last night I put up a video where you'll probably tell I was very, very pleased and surprised and excited. This is just a very brief video too. But yeah, I put up a video showing just how insane this thing was getting out. So this is one of my new electric dipoles. I probably won't be putting up a how to build. It is very complicated. So this version, so essentially, like one of my previous videos, the idea behind it is for it to act as a complete antenna by itself, whereas normally you have a whip that is one side of the antenna and the cardboard is the other, where this is two sides to an antenna. So essentially an electric dipole, and I'm saying electric dipole because it's working with the E fields and not about the direction of current flow. Okay, so it has an electrical resonance where each element are opposing voltages and at high voltages, higher than normal. It's a high Z system, so without an ATU it presents an infinite impedance. Okay, and remember, infinite impedance, that's infinite impedance to the flow of current. And when you impede the flow of current, you have the opportunity to take advantage of the increase in voltage. So, it's great. It just screws on like any other whip. So that is a bonus. Now, the actual, this one's built on what was like a ham stick or whatever you call it. So it had the fiberglass whip and then the steel whip. And originally this was like for the 40 meters. So it had quite a standard loading on there. And by the way, as a 40-meter ham stick, it was absolutely rubbish. Oh yeah, you could tune it in, and it was very narrow, and as you'd imagine from a ham stick, it was crap. Okay, so stripped it all off, and now the basically the connection from here travels all the way up to the middle here, but on top of that, so that's sort of hidden like the center conductor of coax now, right? And then I have some insulation, and from here up is the bottom element of the electric dipole. Now at the top, well, the steel whip section is the top element of the electric dipole. Now, this is where it gets insane. This is, I'm still not sure what to call it, but this particular one is using a complex dielectric inductor, or you could call it dynamic capacitance system, along with, this one's pretty simple on the inductor side, the normal magnetic inductor. This has a conical Tesla bifilar pancake coil, bridging the two sides of the electric circuit, of the antenna circuit system. So technically you could say this is an LC oscillator in a way. Now it has a torus at the start of each element too. This increases of course the magnetic inductance of the elements, but it also increases the capacitive loading between the two sides of the system, and it also increases its engagement with the outside world, which is what our antennas are all about. And down the bottom here I have another conical Tesla bifilar pancake coil that bridges the end of the bottom element to the actual input of the system. Okay, so that's one. And then following that, last night I then built, because I was so excited, had to build another one. So this one is on a 9-foot stainless steel whip. Now it's going to be hard to see. So same principle. The whip is the inner conductor. I have insulation and then copper sleeve over, so then that becomes the bottom element. And same with the top of the whip. This one has insulation over it and then copper, so that becomes the top element. But this one is different and very, very insane. This one uses my complex, I don't know what it's called, complex dielectric inductance system, or dynamic capacitive system, along with, instead of a Tesla bifilar pancake coil, this is one of my trifilar feedback loops. And insane and ultra simple. So this will be the basic design that I'll be running with, and the output is just unbelievable, to the point where people won't believe me and they'll go, oh, that bloody guy, he's not licensed for 600 or a kilowatt. Maybe it's not that good, but you know what I mean. It's definitely behaving on HF like definitely not like 10 watts. What led me to these discoveries was this, and I never did do a video on this, but this was the start. Now this was an 80 meter band experiment, okay, and it was actually remarkable. Now this is an infinite impedance system. I'm keeping this just to show anyone interested down the track, but I found that on, like, so you can imagine these conical bifilar pancake coils is like a step-up transformer for the top element. What I found is, because though they're bifilar and it's like capacitive, if I ran one wire around the hottest one, the top, your highest voltage, which was just coupling with the capacitance between the two wires, and then doubled that back, it gave me a feedback loop system. Now this, when you connect it to a transceiver, wow, you can tell it's just fully alive, it's got massive ears, but you hit transmit and you've got an infinite impedance. So it's highly resonant with an infinite impedance, okay? Because there is more than one type of resonance. And so but this, of course, I'm not going to run with this particular design. This was like a stepping stone. This still had a massive back EMF when tuned, and that's why this one had to have here a coaxial choke. But this is a coaxial choke done rigged just like a bifilar pancake coil, which really increases the through inductance collectively, dielectric and magnetic inductance. So if you are ever wanting to make a coaxial choke, what a fantastic way to do it, okay? So the idea is it's just coming in, spirals all the way outwards, then jumps back to the middle, and on top spirals all the way outwards. But, you know, so this one is enough to be an effective choke for 80 meters. You'd want to probably go twice as big for 160. So, but if you're uncertain, what you do is just once you've made one, then just put a LC meter across the ground on the input and the ground on the output, and see what the inductance is looking like. And provided the inductance is higher than, use it like an LC calculator. You know, you can get those, I've got one called LC Circuit Pro. It's a great app. And if you just enter in the band you want, like the frequency, and choose the result with the lowest capacitance, then you know you've got your highest inductance for that frequency, and make sure your inductance is higher than that, and then it will be an effective choke. But yeah, this I'm holding on to, very good, but mono-banded, couldn't get it to tune up on anything else, but completely sensitive on 80 meters with an infinite impedance. So then I just had to tune to it. But yeah, my new approach, but that led me, it was a stepping stone. My new approach is just amazing and so simple. So this one, of course, being a 9-foot whip, it's big enough to not need, you know, the hideous Tauruses and stuff like that, where this one is a shorter whip, so I've had to sort of put these on to make up for it, but it looks kind of a bit ridiculous, I guess. But, you know, I'll keep going. 7.3, and thanks for watching.